Welcome back to learning multiple skills at solving word problems that involve sketching, placing the given numbers on your drawing, um, recognizing the triangles you have in your drawing, and applying the sine and cosine rule accordingly to find missing sides, missing angles, and sometimes the bearing. I left this question for you in the previous video, but before I get started with solving this word problem here, I would like to warm you up with the following question. So, in this question, for the points C, which is 0, 2, and D is 5 and 9, calculate the angle between C and D and the y-axis. At first, once you see the coordinates of any points, you need to draw the coordinates plane, x-axis, and vertical on it the y-axis. And then you need to plot each point that is given to you in the question. You start at 0, 0. The first number, which is the 0 here, is how many units you need to move on the x-axis. So if it's 0, then you stay here. The 2 is telling you how many units to move in the y-axis, and since it's positive 2, then you need to move up 2 units. So the plotting is as following. This is C. Now, to plot D, you're going to start at the original point, and you're going to move on the positive x-axis towards the right 5 units. 1, 2, 3, 4, 5. You stop here, and then you need to move up since 9 is positive. 9 units. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the plotting of this of point D is as following. Now, let's draw this line. Let's connect the 2 points together. And let's find the triangle. As you can see, this is opposite, the opposite side, which is 5, the opposite side to this angle, because they said the angle between CD and the y-axis. So if this is our C, this is D, this is line CD, and the intersection with the y-axis. So this is the angle that we're looking for. So this side is 1, 2, 3, 4, 5 units long, and it is opposite to the angle. It's the opposite side to the angle that we are trying to find. And this side here is the adjacent. And why it's 7 units? Because if you start the counting from point C here, 1, 2, 3, 4, 5, 6, 7 units long. We have here a right-angled triangle. So this is my unknown angle. We're going, since the opposite and the adjacent are the known sides, then tan the unknown angle is equal to opposite over adjacent. Let's substitute. Tan the unknown angle is equal to 5 over 7. This is tan of the angle, of the unknown angle. We want to find the unknown angle, so we're going to apply tan inverse on each side. So tan inverse of 5 over 7. This is ready to be inserted in the calculator, And if we insert this in the calculator, we're going to find the unknown angle as 35.5. This is correct to three significant figures. The 3 on your left is the first figure, the 5 is the second, and the 5 after the decimal is the third figure. Look at the right of the 5. 3 is less than 5, so it's not going to bring my 5 up, which leaves my answer correct to three significant figures as 35.5 degrees. Another question that I would like you to deal with before we get back to the question that I displayed at the very beginning of this video, and we're going to use the exact same skills for the points P, Q, R. The coordinates of each point is given to us, so we're going to start by drawing the coordinate plane. Horizontal x-axis and vertical on it the y-axis. Let's start with plotting the points 2 and 5. So you start at the origin, you move towards the right 2 units and then up 5 units, and this is the plotting of P. Now, point Q, you start at the origin, you move towards the right 5 units and then you go up 1 unit. So this is the plotting of point Q. Point R, you start at the origin, so you don't move towards the right or the left on the x-axis because the x is 0 here, and then you're going to move down 3 units because 3 here is -3. So this is the plotting of R. Then connect the 3 points together. Start from P to Q, Q to R, and then R to P. So this is our triangle. If this is angle P, then the opposite side to angle P is P small. This is the opposite side to angle P. If this is angle Q, then the opposite side to angle Q is this side, PR. If this is angle capital R, then the opposite side to angle R is PQ. So this is small r. Now, none of the angles and none of the sides are known. So we need to use an old information that we know, which is finding the distance between 2 points. Let me remind you about this skill. None of the sides in triangle PQR is known. Then use the rule of finding the distance between 2 points as following. Let's take P and Q, and the general rule of finding the length of a line is square root of the difference of the x to the power of 2 plus the difference of the y to the power of 2. So, since we have the 2 points here, we need at first to identify x1 and x2 as following. x1 is 2, x2 is 5. And then we need to identify y1 and y2 as following. y1 is 5 and y2 is 1. Let's substitute in the general formula. So we're finding PQ is equal to 2, the difference of the x, 2 minus 5 all to the power of 2 plus the difference of the y, 5 minus 1 all to the power of 2. This is ready to be inserted in the calculator. So PQ is equal to 5 units. PQ is basically the small r. So small r is equal to 5 units. Let's go now to the second 2 points or the second line. So we're going to calculate the length of line QR. So point Q and point R. Let's identify the x's. x1 is 5, x2 is 0. And then let's identify the y's. y1 is 1, y2 is -3. Let's substitute the x's and the y's in the general formula. So we're finding the length of QR is equal to square root of the difference of the x's, 5 minus 0 all to the power of 2 plus 1 minus 3, because the first minus, which is in black here, is part of the rule or of the formula, the general formula, and -3 is the value of y2. This is ready to be inserted in the calculator, and if you calculate it, you're going to find QR as square root of 41, and units is the measurement unit. So QR represents P small. So P small, because it is right opposite to angle P, so this is side P, and the value of it is square root of 41. The last side that we have is RP or PR. So R and P, we place the 2 points next to each other. We're going to identify the x's. So x1 is 0, x2 is 2, and then we're going to identify the y's. y1 is -3, y2 is 5. Let's substitute the values of x and y in the general formula as following to find the length of RP. So it's a square root of 0 minus 2 all to the power of 2 plus -3 minus 5 all to the power of 2. This is ready to be inserted in the calculator, and the answer will be for RP as 2 square root of 17 units. RP represents Q small, so the value of Q small is 2 square root of 17. Now we found the length of each side in this triangle. Let's move to the next step. So once again, the coordinates, the plotting, we connected between the lines, we found our triangle, we identify each angle, the opposite side to each angle, and then we applied the general formula of finding the length of a line between 2 points, and we found the length of each side in this triangle. Now this triangle is ready to apply the sine or the cosine rule on it. I'm going to start with the cosine rule. Use the cosine rule to find the length of, this is not the length, the size of angle PQR, which is angle Q. So PQR, or we call it RQP, or we call it capital Q, angle capital Q. So here use the cosine rule to find the size of angle PQR, or we call it angle Q capital. So since we're finding Q capital, we're going to start our formula by writing Q squared. We start with the opposite side to Q. So Q squared is equal, what are the other two sides? P and R. P squared plus R squared minus in brackets 2 times P times R times cosine the angle between the two known sides. The two known sides, R is 5, P is square root of 41. So the angle between the two known sides, cosine Q. Now let's substitute in this formula. So Q is actually 68 because if you put square, because if you put 2 square root of 17 all to the power of 2, you're going to end with 68, and then p squared. So p squared, p is square root of 41, so p squared is equal to 41, and then r squared, so it's 5 to the power of 2, and this one will be 25, and then here it's going to be 2 times p, which is square root of 41, times 5. 2 times 5 is 10 square root of 41 times cosine q. Now, 68, if you simplify 41 plus 25, it's going to be 66 minus, in brackets, 10 square root of 41 times cosine q. Now, we want to get rid of 66. Why? Because we are solving for q. We are solving for q, so we're going to get rid of any numbers before cosine q. So we're going to leave everything that's inside the bracket, and we're going to get rid of 66 at first. How? We're going to apply opposite operations. So we're going to subtract 66 from each side of the equation. So as you can see here, 68 minus 66, and here minus 66. Why? Because I want to cancel the 66. So 66 minus 66, the 66 is gone in this side. And 68 minus 66 is 2, is equal to negative 10 square root of 41 times cosine q. Now we're going to get rid of negative 10 square root of 41. How? We're going to apply opposite operation. If you read it, 10 square root of 41 times cosine q. What is opposite to times? Divide. So we're going to divide all or each side of the equation by negative 10 square root of 41. And so it's going to be 2 over, because over it means divided by, negative 10 square root of 41 is equal to cosine q. This is the value of cosine q, but what we are trying to find is the value of angle q. So we're going to apply again opposite operations. So we're going to apply cosine inverse on each side. So cosine inverse of 2 over negative 10 square root of 41 is equal to q. This is ready to be inserted in the calculator, and this will bring q down to 91.78991061. And if you round this answer to 3 significant figures, you're going to stop at the 7. Look at the right, 8 is greater than 5, so this will bring my 7 up. So the final answer correct to 3 significant figures is 91.8 degrees, and this is the value of q. Now that I received some questions on why don't I use the sine rule, for example. Okay, let's try this together. Again, the coordinates, the plotting, connect the points together, find your triangle, name the angles and the opposite sides to each angle, and then we found the length of each side by using the general rule of finding the length between two plotted points. Now using the sine rule. Q, the length of the side, over sine of Q is equal to the second fraction, the length of side P over sine of angle P is equal the third fraction, the length of side R over sine of angle R. Now, if we substitute, the length of Q is 2 square root of 17 over sine Q. The length of P is square root of 41 over sine P. And then the length of R is 5 over sine R. As you can see here, if I take these two fractions together, the first two fractions, I have two unknowns, Q and P. So this equation cannot possibly be solved. And if I take the second two fractions, so I have P and R as unknown, and again, two unknowns, so the equation cannot be solved. So we can't use, in this case, the sine rule to find the missing angles. Now, let's get to the question that I started my video with. And like I said, when you have a question, you start by drawing the question. As you're reading the question, you start drawing the question or a sketch for the word problem here. So, he observes the angle of elevation of a lamp post on the other side of the road to be 27 from the edge of the road and 15 from a point that is 10 meters back. So I have a lamp, and if he's standing here, this is the lamp. The angle of elevation here, which is 27, okay? And then the question says if you go 10 meters back, and this will be the angle of elevation as 15 degrees. So that's what's given to me in the question. This is the diagram that represents this question. Now, based on what's given, as you can see, this is one triangle, this is a second triangle, and the big triangle. So I have three triangles basically. Okay, let's start. If I name this angle, this given angle, as A capital, then the opposite side to A capital, which is the length of the lamp, is A small. This angle here is definitely 90 degrees because the lamp is always vertical on the ground floor. So if I name it as B, then it's equal to 90. Then this black hypotenuse, which is right across the 90 degrees, is actually B small. The third angle here is C, which is equal to 63. Why 63? Because if I add 27 and 90 and I subtract the result from 180, I will end up with 63. The opposite side to angle C is basically C small. If I go to this triangle, if I name 15 as M, capital M, this angle here, the side that is opposite to capital M, to angle capital M, is small m, which is equal to B. B is the hypotenuse of the black triangle here because it is right across and right opposite to angle B capital. So B is equal to M. Now, This angle, if I name it n, how can I find the value of n? So, as you can see, n and a, they are angles on straight line. So, angles on a straight line add up to 180. So, if I subtract 27 from 180, I will find n as 153. There is one small angle that's left here. Sorry, once again, this is my angle n. The opposite side to angle n is the blue hypotenuse. So this is a small n, which is unknown. Now, the last angle is this small angle here. If I name this m, this n, let's name this one as q, for example. Q is going to be 12. Why 12? Because 15 plus 153, when you add them and you subtract the result from 180, you will find the 12 degrees, because angles in a triangle add up to 180. The opposite side to Q is the 10m. Now that we identified everything on this diagram, I will leave this question for you to apply the sine and cosine rule on it, and I'm going to solve it in details for you in the next video. Thank you so much for watching and for liking this video and for sharing and subscribing to my YouTube channel.